As we wrap up GDP, I want to look at something sometimes referred to as the standard of living. I want to pull a quote from a guy by the name of Andrew Yang. And Andrew Yang was running for president for a short time in the 2020 election. And here's what Andrew Yang had to say about GDP. Traditionally, the economy has been measured by looking at the gross domestic product. However, even the creator of GDP admits that it doesn't really reflect the full story. And rising GDP has virtually no relationship with each citizen's well-being. Now, here's the thing is, how do we measure standard of living? Well, standard of living is kind of defined as the level of wealth, comfort, material goods, and necessities available to a certain socioeconomic class or a certain geographic area. Well, in this case, the standard of living in the United States, we're referring to the geographic area of the United States. Yet our own Federal Reserve Bank has been quoted by saying yet that generally accepted measure for standard of living is the average real gross domestic product per capita. And so we can see that there is kind of this, back and forth on whether or not this should be used to measure the overall standard of living or how life is for people within a country. But nonetheless, we typically see that real GDP per capita, as the Federal Reserve Bank of Boston says, is what's typically used. And so real GDP per capita is just the way that we find out how much GDP is produced per person in a country. So to find that, we take the real GDP per capita, we'll divide the country's real GDP by their population, and we get the average output or average GDP per person. So we just take real GDP over the population. So about a couple years ago, we saw that the United States GDP was a little over 19 trillion, and the population was a little bit over 329 million. Well, if you take that real GDP and you divide it by the population, you find out that the GDP per capita was $58,365. Now, one thing I want to make clear is this is not saying that the average income of a person in the United States is $58,365. It's just trying to give us a measure of okay, per person in your country, how much stuff or how much value worth of stuff do you produce? And typically what we see is that the higher that number is, the more productive that country is. So let's take a look at two other countries. Let's take a look at Japan and Uganda. And you might already have an idea about where these GDPs per capita could fall without even doing much of the math, just by what you know about these countries. But if we take the GDP of Japan and divide it by their population, we see that they have a GDP per capita of $40,316.21. If you take Uganda's GDP and divide it by their approximate population, you get a GDP of $633.33. And so that can just kind of show us from country to country about what is their standard of living. Because as the Federal Reserve Bank said, that's what we typically use to measure that. But again, Andrew Yang, someone who's running for president, was kind of going against this, saying, well, is this a proper way to measure the standard of living? So as we move on and talk more about macroeconomics, we want to refer back to the graph that we saw in microeconomics when it comes to supply and demand. Now, we're going to be doing a lot more with this graph as we go throughout the unit, but we want to at least introduce some things as we get started. So just to recap on this supply and demand graph from microeconomics, if you remember, along our x-axis, we had our quantity, just the amount of a product. Along our y-axis, we had the price. What is the dollar amount of each one of those products? And then we had our demand curve, which was downward sloping, our supply curve, which was upward sloping. And we said that the intersection of those 2 points, where the quantity demanded equal the quantity supplied, is known as our equilibrium. And there is some equilibrium price with some equilibrium quantity where we can see at what specific price is the amount that people want exactly equal to the amount being provided. But remember, again, with microeconomics, this is specific to an individual market. Well, what happens when we're trying to look at the entire economy? Well, this graph is going to look similar, but it's going to have some key differences. So whenever we look at our axes are going to be kind of the same, but instead of quantity along our x-axis, we're going to have our real GDP. Because rather than just telling us what is the total amount of that product made within a market, we want to look at the total amount of all products made within the entire economy. Now, we can't use quantity here because obviously the quantity of airplanes means something different than a quantity of pencils. Like if we make 10 airplanes, that's a lot more productive than making 10 pencils. So instead we use real GDP to measure the value of those things. Then instead of having our prices, we are going to have our price level. Our price level is an index telling us what is the average level of prices within the economy. Because again, think about airplanes and pencils. The actual price of those things vary by so much. And because they vary by so much, we can't really plot all of that from pennies all the way up to millions of dollars on a single axis. So instead, we use price level to understand what is the average level of prices within our economy. And then instead of just our demand for a specific product, we're going to have our aggregate demand. Our aggregate demand shows us what is the total amount of goods and services, the total dollar amount of stuff demanded within our economy at every price level. And aggregate supply shows us what is the total dollar amount of goods and services produced within the economy at every price level. And then we're going to have some equilibrium. We're at our equilibrium. It is the price level at which the dollar amount of goods and services demanded is equal to the dollar amount of goods and services being supplied. So as you guys can see, a lot of similarities here within the macroeconomic supply and demand model, or what we call the aggregate supply and aggregate demand model, but there are some key differences. Now we're going to focus in today on the difference that comes with that y-axis, the price level, and trying to understand exactly what a price level is. A price level is just the average level of prices within an economy, and we typically use different price indices in order to determine that. Now, a price level, or these price indexes, attempt to tell us what is the average level of prices within an economy, because obviously those prices fluctuate from year to year. Now, a general increase in those price levels we call inflation. It's starting to rise. It's getting bigger. And a general decrease in price levels we call deflation. Now, what do we use in order to measure these? What indexes do we use to measure inflation and deflation? Well, there's a couple that are different ones that are used within the economy. We're going to focus in on two of them specifically. So we have Consumer Price Index, known as the CPI, GDP Deflator, sometimes known as the implicit GDP or implicit deflator. And then we also have Producer Price Index. Now we're going to focus in on these first two, CPI and the GDP Deflator, as we go. And we want to understand how do we use these in order to determine how do prices change over time. So let's start off with our Consumer Price Index. To understand the differences between these different price indexes, we want to kind of look at what the name is. And here, obviously, it's the Consumer Price Index. So this is an index that lets us understand how prices change over time for goods that are typically purchased by people like you and me, by just everyday consumers, because those are the prices that we care the most about. And so what's done is there's actually this kind of shopping list that's been made up. And every single month, the BLS goes and they go shopping for all these items, and they want to understand how do the prices of these items change from month to month to month. So there's a few steps that we do. First of all, we need to calculate the current basket value. And what we mean by that is when we say basket value, we're saying, okay, that shopping list of typical things that people go and purchase, we want to add up what is the total amount of that right now. And then we're also going to compare that to what was that same shopping list price back in some base year. Now, the Bureau of Labor and Statistics, the BLS, they actually use 1982 as the base year. That's the year that we use the shopping list from 1982. We use the prices in 1982 to be able to compare every single year back against that one. But you might see sometimes on some of your problems and your homeworks that we'll use a different year. We might not use exact years. We might just use, year 1, year 2, year 3. But what we do is we want to understand what was that same shopping list worth back in 1982 or in our base year, and then we can compare the two. We use the market basket value from whatever our current year is and from whatever that base year is in order to find this index. And so the formula that we have here is that our CPI, or that index, is equal to the current market basket value, so whatever it is in this current year, divided by whatever it was in our base year, and then we multiply that by 100 to get our index. Now, one thing I want to make incredibly clear, when we talk about this consumer price index, we're not referring to it as a dollar amount. We're not referring to it as a percentage. It's just an index. It's just a number. So let's take a look at how this might work out. Let's say that the market basket value, the worth of that shopping list in 1982 is $21,895. Well, the nice thing is about the base year, you're dividing that year, that current year, divided by the base year, which is also the same year. And so any number over itself times 100 is going to be 100. And so the CPI in the base year is always going to be 100. And remember, like we said, this is just an index, not a percentage, not a dollar, just a number. Now, what about when we look at the year 2001? Let's say we're in the year 2001. We go shopping for those same items and we find out those items now cost $43,567. Well, what we do is we take the market basket value in 2001, divide it by the market basket value in 1982. So we do 43,567 divided by 21,895, multiply that by 100, and we get an index of 198.98. We can do the same thing for 2005. Divide 46,397 by whatever that value was in our base year, 21,895, and we get 211.91. And then in 2007, we do the same thing. 47,873 divided by our base year, 21,895, and you get 218.67. But once we have these index numbers, well, what exactly do we do with them? Well, what we can do once we have these index numbers is we can calculate our inflation rate. Once we found those, we can use those to find the percent change, and that percent change is what we call of our inflation rate. By what percentage did prices change between any 2 years? And so what we do is we'll take the CPI in year 2, which is just the later of the 2 years, minus the CPI in year 1, the earlier of the 2 years. And then we divide it by the CPI in that starting year, and we multiply it by 100. Now, here's what we end up seeing, guys, is really this is just the percent change formula. It's saying what was the change divided by our starting point. And because we've already found our index numbers, we no longer have to worry about that base year to find the inflation rate. Like we've already used the base year to get everything in some common way to measure it, this index. And so from here, we can then compare any 2 years that we want. So we could compare 2001 to 2007. We can compare 2001 to 2011 or 2007 to 2011. We can use any of those, and that's great. And so really what this is saying is it's just the change in our CPI over our starting point times 100. And that will result in a percentage. And that percentage is the inflation rate. Now, something very similar to CPI is what's known as the GDP deflator. And GDP deflator, instead of using a shopping list of things people typically buy to measure how prices changes, GDP deflator uses the entire GDP to understand how prices have changed. So what we end up doing here is we have to solve for the nominal GDP, and then we also have to solve for our real GDP. And so step number 1, we solve for our nominal GDP. So we find the GDP using current year prices. We determine a base year and use that base year to find our real GDP. And then we calculate the GDP deflator. Again, this is just going to be an index. And so our GDP deflator is equal to our nominal GDP in a given year divided by the real GDP in that given year times 100. And again, since nominal GDP is equal to the real GDP and whatever our base year is, again, the base year is always going to be 100. But like I said, the difference here between the two is the CPI only measures price changes in goods and services that consumers typically buy. GDP deflator measures price changes across the entire economy. Another really cool thing I want you to see is that GDP deflator and CPI are actually way more similar than you realize. Remember with CPI, our formula was doing the market basket value in the current year divided by the base year. Well, GDP deflator takes our GDP using a base year's prices or a current year prices divided by base year prices. So it's always doing something with the current divided by something with the base, right? Whether it's the current market basket value divided by the base year market basket value, or the GDP using current prices divided by the GDP using a base year prices. So they're pretty well the same in that sense, right? Now, in the same way, we can then use our GDP deflator indexes to calculate the inflation rate. Once we found those indexes, we can use that percent change formula to find that percentage. So we would take our GDP deflator in year 2, again, year 2 just being the later of the 2 years, minus our GDP deflator in year 1, the earlier of the 2 years, divide that by our year 1 GDP deflator, that starting point, and we multiply it by 100, and it gives us an index, or it gives us the percentage based on those indexes, the percentage of how much did prices change from one year to the next. And then again, the way we can look at this is just the change in the GDP deflator divided by our starting point, our year 1 GDP deflator. So again, same formula that we end up seeing for the CPI. Now, a couple different types of inflation I want you to be aware of. One is known as the demand pull inflation. The other is known as cost push inflation. Well, what exactly do these mean? Well, when we look at our graph, which we're going to see in a second, we're just talking about whenever prices change, just whenever, like how we saw that prices could change based on a change in supply or demand in microeconomics, the same thing is happening but in macroeconomics. Demand pull inflation is caused by an increase in the aggregate demand curve. Cost push inflation is caused by a decrease in the aggregate supply curve. So let's talk about exactly what that means. Demand pull inflation means that our aggregate demand curve is increasing, or really what we're saying is that people are demanding more products as a whole across the economy. And so just like with our microeconomic model, we see that would be reflected as an increase in the demand curve. But as that demand increases, what we see is an increase in our price level because we see that we now have more goods being demanded. And because of that, we see our equilibrium increases. And as our equilibrium increases, not only do we see our price level rise, but we see the total market value of all goods and services being demanded and supplied increases. And so one way that inflation or raises in price can occur is by an increase in our aggregate demand curve. The other way is cost push inflation, which is typically seen because we see that the inputs in production have gone up in price. And so we would see that cost push inflation as a decrease in our aggregate supply curve. So as inputs in production go up in price, we would see that our aggregate supply curve would shift back to the left. And what that does is it would also cause an increase in our overall price level. And that increase in our overall price level is known as inflation. Now, a couple other key things to know about inflation is that typically we see something in our economy known as creeping inflation. Creeping inflation is just the idea that on average, we typically see somewhere between 1% to 3% inflation, and that is totally normal. That's totally normal in a growing economy. So if we look at our historical inflation rates in the consumer price index, that little green bar across there is the 1% to 3% rate. And if you guys see, that's totally normal. That's something that we typically have. There were some times during the 1970s, as you guys might know from your U.S. history classes, that we experienced some pretty extreme inflation. But outside of that, throughout like 1990 to present day, it's pretty well stayed in that 1% to 3% range. So there is typically a direct relationship between GDP growth and inflation rate. We say that as GDP increases, so does inflation, and then as GDP decreases, so does inflation. Inflation starts to go down, possibly to the point of deflation, where we see those negative changes in prices. And this is something that's actually reflected in a model known as the Phillips curve. Sometimes we also see something known as stagflation. This is something we actually saw back in the 1970s, where we saw inflation mixed with a stagnant or a non-growing economy. So we say that typically there's a direct relationship between GDP growth and inflation. We actually saw that was not the case but in the years of the 1970s. We saw that inflation was going up at the same time that our economy was going down. And so that can sometimes happen. It doesn't happen all that often, but that's kind of a double whammy on our economy. And then finally, hyperinflation. We've seen this historically, mainly if we think about like Germany post-World War I. We think about it when we think of Zimbabwe in the 2000s. Sometimes when the money supply grows too fast, people, as they get more access to money, they can demand more stuff, and demand pull inflation drives prices up so incredibly rapidly, sometimes by the thousands of percentage per day. Now, again, we don't see this happening very often, but we have seen instances of it historically. Like I said, most recently, we saw it in Zimbabwe, where Zimbabwe got to the point where they were printing $100 trillion bills. And that's because they got to the point where their prices were doubling every 24 hours and 31 minutes because they were printing money and printing so much of it.